Tonight, we examine the critical state of our planet's most vital resource.
Across the globe, these once fertile lands are turning to dust.
Somewhere in Lancaster County, Pennsylvania, a man in a straw hat and suspenders is plowing a field with 2 horses. No tractor, no GPS guidance system, no satellite-linked soil sensor, no genetically modified seeds, no synthetic fertilizer, no pesticide, no herbicide, no fungicide, nothing manufactured in a chemical plant. Just a man, 2 horses, a steel plow, and the same method his grandfather used, and his grandfather before him, and his grandfather before him, stretching back 300 years to the original Amish settlers who arrived in Pennsylvania in the 1730s. This man produces food on roughly 80 acres. His neighbor, a conventional industrial farmer, produces food on 800 acres using a $400,000 John Deere combine harvester equipped with AI-driven yield monitoring, variable rate fertilizer application, and real-time satellite imagery. The industrial farmer uses roughly 200 pounds of synthetic nitrogen per acre, plus herbicides, insecticides, and fungicides. He produces slightly more bushels per acre than the Amish farmer. Slightly. Not dramatically more, slightly. And his soil is dying. Not metaphorically, measurably, quantifiably, provably dying. Losing organic matter at a rate of 0.1% per year. Losing topsoil at a rate of roughly 1 inch per decade. Losing the biological infrastructure that makes agriculture possible, 1 spray season at a time, 1 heavy machinery pass at a time, 1 synthetic nitrogen application at a time. His great-grandchildren will inherit a field that produces half of what it produces today. The Amish farmer's great-grandchildren will inherit a field that produces exactly what it produces now. Because the Amish farmer is not depleting his soil, he is building it. He has been building it for 300 years, and the AI just proved it. In 2023, a team of agricultural scientists used AI-powered soil analysis, machine learning models trained to process hundreds of biological, chemical, and physical soil indicators simultaneously to compare the health of soil on traditional Amish farms with the soil on conventional industrial farms in the same county, the same climate, the same rainfall, the same latitude, same dirt, same rain, same sun. The only difference was how the land had been treated for the last 50 years. What they found was not subtle. It was not a marginal improvement. It was not a minor statistical edge that required a footnote to notice. The Amish soil was alive. The industrial soil was not. And the gap between them was so large that the lead researcher said something that no agricultural scientist is supposed to say out loud. What we are doing to our farmland is not farming. It is mining. And when the mine is empty, there will be nothing left. Before we talk about what the AI found on Amish farms, you need to understand what is happening to farmland in the rest of the country. Because this is not a story about the Amish, but it is a story about the catastrophe that industrial agriculture is creating underneath our feet while nobody is paying attention. The United States has lost roughly 1/3 of its topsoil in the last 200 years. Topsoil is the upper layer of Earth, where plants grow the dark, rich, living layer that contains organic matter, microorganisms, fungi, insects, and the complex biological infrastructure that makes agriculture possible. It takes nature approximately 500 years to produce 1 inch of topsoil. Industrial agriculture can destroy that inch in a single season of deep tillage. The average American farm today has topsoil between 6 and 8 inches deep. A century ago, it was 12 to 18 inches. The math is simple and terrifying. At current rates of erosion, the United States has roughly 60 years of topsoil left, 60 harvests. After that, the soil becomes what scientists call subsoil, a biologically dead mineral layer that cannot support crops without massive inputs of synthetic fertilizer. And synthetic fertilizer is part of the problem. When you dump 200 pounds of nitrogen on an acre of land every year, you are not feeding the soil. You are bypassing it. You are telling the plants, ignore the biology beneath you. Here is your nutrition in a bag. And the biology beneath responds by dying. The microorganisms that naturally convert organic matter into plant-available nutrients, the bacteria, the fungi, the protozoa, the nematodes, have nothing to do. Their food source, organic matter, is not being replenished because crop residues are removed or burned. Their habitat, soil aggregates, is being shattered by heavy machinery. Their community, the soil microbiome, is being poisoned by herbicides and fungicides that do not distinguish between harmful organisms and beneficial ones. A tablespoon of healthy soil contains more microorganisms than there are people on Earth. A tablespoon of heavily farmed industrial soil can contain less than 10% of that number. The soil is not just dirt. It is an ecosystem, the most biodiverse ecosystem on the planet. In fact, a single gram of healthy soil contains up to 10 billion bacteria from thousands of different species, plus fungi whose thread-like hyphae can stretch for miles in a single acre, plus protozoa, nematodes, mites, springtails, and earthworms that together process more organic material per year than every above-ground animal on the farm combined. This underground city does not just exist in the soil. It is the soil. Without it, you have sand and clay. You have geology. You do not have agriculture. And industrial agriculture has spent 70 years systematically destroying it. But the soil crisis is not just about soil. It is about water and food and human health. And when soil loses its biological structure, it loses its ability to absorb and filter water. Healthy soil acts like a sponge. A single acre of soil with good aggregate structure can absorb over 20,000 gallons of water in an hour. Compacted, biologically dead soil absorbs a fraction of that. The rest runs off. And that runoff carries two things with it: topsoil, which clogs rivers, silts up reservoirs, and smothers aquatic ecosystems, and chemicals, the nitrogen, phosphorus, herbicides, and pesticides that the farmer applied to the field and that the soil could not absorb because the biology that would normally process them is gone. The dead zone in the Gulf of Mexico, a 6,000 square mile area where nothing lives because the water contains so little oxygen that fish, shrimp, and crabs suffocate, is caused almost entirely by nitrogen runoff from Midwest farmland carried down the Mississippi River. The algal blooms that poison Lake Erie's drinking water every summer are caused by phosphorus runoff from Ohio farms. The atrazine contamination in the groundwater of Iowa, Nebraska, and Kansas, an herbicide linked to endocrine disruption, comes from fields where the soil can no longer hold what is being poured onto it. And then there is the food itself. Studies published in the Journal of the American College of Nutrition have documented measurable declines in the nutrient content of American crops over the last 50 years. Today's wheat contains roughly 28% less iron, 34% less zinc, and 16% less magnesium than wheat grown in the 1960s. Today's tomatoes contain 43% less vitamin A than they did 50 years ago. The crops look the same, they weigh the same, they even taste similar. But they are nutritionally hollowed out because the soil they grow in has been biologically hollowed out. The plants cannot absorb minerals that the soil microbiome is no longer making available. The Amish never started any of this. And their food, grown in living soil, managed the same way for 3 centuries, tests consistently higher in mineral content than food from industrial farms. Not because of magic, because of biology. Because the microorganisms in their soil do what microorganisms have done for 400 million years: break down organic matter and deliver nutrients to plant roots in exchange for sugars. A transaction that has worked since before dinosaurs existed. A transaction that industrial agriculture replaced with a bag of chemicals and a prayer. The old order Amish farm the way they have always farmed. Not because they are romantic, not because they are backwards, not because they reject technology on principle. They reject it because their theology says that separation from the modern world and reliance on community, manual labor, and divine providence is the path to a righteous life. Farming is not an industry to them. It is a covenant with God and the land. The practical result of that theology is a farming system that, without intending to, follows almost every principle of what 21st century soil scientists call regenerative agriculture: crop rotation, cover cropping, animal integration, minimal tillage, no synthetic inputs, closed nutrient loops. Exactly the practices that the most advanced agricultural research programs in the world are now advocating as the solution to the soil crisis. On an Amish farm in Lancaster County, a typical rotation might look like this: Year 1, corn. Year 2, oats with a clover undersowing. Year 3, hay. Year 4, back to corn. So, the clover fixes nitrogen from the atmosphere into the soil, the same nitrogen that industrial farmers buy in bags from chemical companies. The hay is fed to horses and cattle. The manure from those animals is composted and returned to the fields. The oat straw is used for bedding, then composted and returned. Nothing leaves the farm that does not come back in another form. There are no bare fields in winter. An Amish farmer would consider leaving soil exposed to winter rain and wind the way you would consider leaving your front door open during a blizzard negligent, wasteful, and embarrassing. Cover crops go in as soon as the main crop comes off: rye, clover, vetch, radishes. Their roots hold the soil in place. Their leaves protect it from rain impact. Their decomposition feeds the microorganisms through the cold months when there is nothing else to eat. The horses matter more than most people realize. A 2,000-pound John Deere tractor exerts roughly 15 to 20 pounds of pressure per square inch on the soil surface through its tires. Over a full season of plowing, planting, spraying, and harvesting, that compaction crushes the soil, aggregates the tiny clumps of particles held together by fungal threads and bacterial slime that create pore space for air and water. Compacted soil does not absorb rain. It runs off, and runoff carries topsoil with it. A horse exerts roughly 8 to 10 pounds per square inch through its hooves, spread across 4 contact points that shift with every step. Horse-drawn equipment is lighter. The compaction is dramatically lower. And Amish fields, after 300 years of horse-drawn cultivation, have soil structure that industrial fields lost decades ago. Nobody told the Amish to do any of this. They did not read papers in Nature. They did not attend soil science conferences. They did not hire consultants from Monsanto or Syngenta or Bayer. They did what their parents taught them, which was what their grandparents taught their parents, which was what worked. And what worked, it turns out, was exactly what the soil needed. And here is a detail that encapsulates everything. Earthworms. A healthy soil should contain roughly 10 to 30 earthworms per square foot. Earthworms are the engineers of the soil ecosystem. They burrow channels that allow water and air to penetrate deep into the ground. They consume organic matter and excrete castings that are among the richest natural fertilizers on Earth, and their tunnels provide highways for root growth. Without earthworms, soil compacts, water pools on the surface, and organic matter accumulates without being processed. Researchers conducting the AI soil analysis counted earthworms in sample plots on both Amish and industrial farms. The Amish fields averaged 23 earthworms per square foot. The industrial fields averaged 3. Some industrial plots had 0. Not a single living earthworm in an entire square foot of soil. Think about that. A living system that has existed for 300 million years, earthworms predate dinosaurs by 200 million years, has been functionally eliminated from some of America's most productive farmland in less than a century of industrial agriculture. The organisms that literally built the topsoil that made American agriculture possible have been poisoned, compacted, and starved out of existence. The Amish fields still have them. 23 per square foot, billions per acre, doing what they have done since before mammals existed, and doing it for free. In 2017, a research initiative was launched to compare the soil health of traditional farming systems, including Amish and Old Order Mennonite farms, with conventional industrial farms in the same agricultural regions of the eastern United States. The study used AI-powered soil analysis platforms that could process dozens of biological, chemical, and physical soil health indicators simultaneously: microbial biomass carbon, microbial biomass nitrogen, total phospholipid fatty acids, enzyme activity rates, soil respiration, aggregate stability, water infiltration rate, organic matter percentage, and the relative abundance of over 10,000 identified microbial species. This was not a simple pH test or a nitrogen count. This was a complete biological census of the soil ecosystem, processed by machine learning algorithms trained to identify patterns in microbial community structure that no human researcher could detect manually. The results, corroborated by a global meta-analysis published in PLOS One that integrated data from 56 peer-reviewed studies comparing organic and conventional farming systems, were staggering. Organic and traditional farming systems like those practiced by the Amish showed 32% to 84% greater microbial biomass compared to conventional systems. That is not a rounding error. That is a biological chasm. The soil under Amish fields contained up to 84% more living organisms per gram than the soil under industrial fields right next door. Microbial biomass carbon, a measure of the total mass of living microorganisms in the soil, was on average 32% higher in organic systems. Microbial biomass nitrogen was 41% higher. Dehydrogenase activity, an indicator of overall microbial metabolic function, was 60% higher. Urease activity, which drives nitrogen cycling, was 44% higher. Protease activity, which breaks down proteins and releases plant-available nitrogen, was 84% higher. Let that last number sink in. The biological machinery that converts organic matter into nitrogen, the nutrient most critical for plant growth, the nutrient that industrial farmers spend billions of dollars a year buying in synthetic form, was 84% more active in the soil that had never received a gram of synthetic fertilizer. The Amish soil was doing for free what the chemical industry charges $15 billion a year to do artificially. But the AI found something even more significant than the raw numbers. It found structural differences in the microbial communities that reveal a fundamentally different ecological reality. The machine learning models analyzed the diversity and composition of soil microbiome communities, the relative abundance of different bacterial phyla, fungal families, and archaeal groups, and found that Amish soil had not just more organisms but a more complex and interconnected community structure. In ecology, this is called functional redundancy, multiple species capable of performing the same essential function. In a functionally redundant ecosystem, if one species dies, another takes over. The system is resilient. It can absorb shocks, drought, flood, disease, and keep functioning. Industrial soil had lost that redundancy. The microbial communities were simpler, less diverse, and dominated by a smaller number of generalist species that thrive in disturbed environments. They were what ecologists call weedy communities, the microbial equivalent of a vacant lot overgrown with dandelions. Functional, surviving, but fragile. One bad season, one drought, one new pathogen, and the system collapses because there is no backup. The AI identified specific tipping points. When soil organic matter drops below approximately 3%, the microbial community undergoes what the models classified as a phase transition, a rapid, non-linear shift from a complex, resilient community to a simplified, fragile one. Most industrial soils in the American Midwest have organic matter between 1.5% and 3%. They are at or below the tipping point. The Amish soils the AI analyzed average between 4% and 6% organic matter. They are well above it. They have never crossed the threshold because they have never stopped feeding the biology. The AI also found that the benefits of traditional farming compound over time. Soil health does not improve linearly, it accelerates. A field managed organically for 5 years is healthier than a conventionally managed field, but a field managed organically for 25 years is dramatically healthier than one managed for 5. The Amish have been farming some of their fields for 250 years. The biological capital they have accumulated in that soil over a quarter of a millennium is, in practical terms, irreplaceable. If you converted an industrial field to Amish methods today, it would take an estimated 50 to 100 years to reach the same microbial diversity. The Amish did not just preserve their soil, they invested in it. For 3 centuries. There is an obvious question here, and the agricultural industry asks it loudly and often. If Amish farming is so great, why does industrial farming exist? The answer is yield. Per acre, per season yield. In a given year, on a given field, an industrial farmer using synthetic fertilizer, hybrid seeds, and chemical pest control will produce more bushels of corn or soybeans than an Amish farmer on an equivalent field. The difference ranges from 10% to 30% depending on the crop, the year, and the specific practices. That yield advantage is real, it is measurable, and it is the foundation of the entire industrial agricultural system. The Green Revolution of the 1960s and 1970s, which saved an estimated 1 billion people from famine by introducing high-yield crop varieties and synthetic fertilizers to the developing world, was built on the premise that maximizing yield per acre is the most important goal of agriculture. More food per acre means more people fed. And for a planet that went from 3 billion to 8 billion people in 60 years, that logic was not wrong. It was necessary. But the AI analysis reveals the fatal flaw in that logic. It does not account for time. Industrial agriculture maximizes yield in the short term by mining the soil's biological capital. It extracts fertility without replenishing it. It borrows from the future to pay for the present. And like all borrowing, it works until the account is empty. The Amish approach produces slightly less per acre per year, but it does so without depleting the soil. It produces slightly less every year forever, versus slightly more every year until the soil collapses. When you model the total cumulative yield over a century, something no industrial agricultural economist has ever been incentivized to do, the Amish method produces more total food per acre, not per year, per century, because it never stops producing, because the soil never gives out. The AI models projected this explicitly, using the measured rates of organic matter decline in industrial soil and the measured rates of organic matter maintenance in Amish soil. The machine learning models estimated that conventional corn yields in the American Midwest will begin declining measurably within 30 to 40 years as soil organic matter drops below critical thresholds. The decline will be gradual at first, a few bushels per acre, and then accelerating as the biology collapses. By the end of the century, without massive intervention, some of the most productive farmland in the world could be producing 30% to 50% less than it does today. The Amish fields will still be producing what they produce now, the same yield they have been producing since before the Declaration of Independence was signed. And there is a study that makes this point with devastating clarity. In 2024, researchers at the Rodale Institute, which has been running the longest-running side-by-side comparison of organic and conventional farming in North America since 1981, over 40 years of continuous data, published an updated analysis using AI-powered predictive modeling. The Farming Systems Trial, as it is called, has tracked yield, soil health, energy use, and profitability on adjacent plots managed organically and conventionally for over 4 decades. The results after 40 years: organic yields matched conventional yields for corn and soybeans during normal rainfall years. During drought years, organic yields were 31% higher than conventional. Because the organic soil, with its intact biological structure and higher organic matter, held more water. The conventional soil, compacted and biologically depleted, could not absorb the limited rainfall. The water ran off, the crops wilted, the organic crops survived. Profitability was also comparable. Organic farms earned similar or higher net income per acre because although their yields were sometimes slightly lower, they had zero cost for synthetic fertilizer, zero cost for pesticides, and could sell at organic premium prices. And when the AI modeled the trajectory forward, projecting soil health trends, yield trends, and input costs. Over the next 50 years, the organic system produced more total food at lower cost with increasing soil health. The conventional system produced less total food at increasing cost with declining soil health. The lines cross around 2050. After that, the conventional system cannot sustain itself without exponentially increasing chemical inputs, and the economics collapse. The organic system continues indefinitely. The AI was unambiguous. One system has a future, the other is on a countdown. That is what the AI found. Not that the Amish are better farmers, that the Amish are farming on a different timescale. They are playing a 300-year game while the rest of American agriculture is playing a 30-year game. And the AI, which does not care about quarterly earnings, or commodity prices, or shareholder value, looked at both timescales and said, one of these approaches has a future, the other one does not. There is one more finding from the AI analysis that deserves attention because it contradicts one of the most fundamental assumptions of modern agriculture. The industrial model says that synthetic fertilizer increases yield because it provides nutrients that the soil cannot provide on its own. More nitrogen equals more growth, equals more food. The math seems obvious. But the AI found that after roughly 30 to 40 years of continuous synthetic fertilizer use, the yield response curve begins to flatten. The soil becomes what agronomists call addicted. It can no longer produce any yield at all without synthetic inputs, because the biological systems that naturally cycle nutrients have been destroyed. The farmer is no longer adding fertilizer to boost production. He is adding fertilizer just to maintain baseline production. He is running to stand still. And each year, the cost of running increases as soil degradation requires more and more chemical input to offset the biological decline. The Amish farmer is not running. He is standing still, and the ground beneath his feet is alive. His nitrogen comes from clover, not from a bag. His pest control comes from crop rotation and diverse planting, not from a spray tank. His soil structure comes from earthworms and fungal networks, not from mechanical subsoiling. The most advanced AI in agricultural science looked at 300 years of Amish farming data and 70 years of industrial farming data and reached a conclusion that the chemical industry does not want to hear. The cheapest, most efficient, most sustainable nitrogen source on the planet is a $3 bag of clover seed and a horse. Not a $400,000 machine, not a $50 per acre chemical application, not a patented seed coating from a multinational corporation. Clover. Seeds that cost less than a cup of coffee, planted by hand, worked by hooves. Producing nitrogen from thin air, the way plants have done it since the Devonian period, 400 million years before anyone filed a patent. There is a man in Lancaster County right now, this minute, walking behind 2 draft horses through a field that his family has farmed for 10 generations. He does not know what machine learning is. He does not know what microbial biomass carbon means. He does not know that the soil beneath his boots contains 84% more living organisms than the field across the road. He does not know that an AI at a university 200 miles away has analyzed his dirt and concluded that his methods are more scientifically sound than the methods taught at every agricultural college in the country. He does not know any of that, and he does not need to, because he was not farming for science. He was farming for God. He was farming the way his father taught him, which was the way his father's father taught him. He was doing what worked, and what worked, it turns out, was what the soil needed all along. The irony is savage. The most technologically advanced analytical tools humanity has ever built, machine learning algorithms processing terabytes of genomic sequencing data, spectroscopic soil analysis running at thousands of samples per hour, satellite-integrated precision agriculture platforms that can map the nitrogen content of a single acre from orbit were required to figure out what a man in a straw hat with a horse and a plow has known for 3 centuries. The soil is alive. Treat it that way, and it will feed you forever. Treat it like dirt, and it will become dirt. That is not wisdom from a laboratory. That is not a finding from a peer-reviewed paper. It is wisdom from a people who never needed a laboratory because they never stopped listening to the land. They never stopped paying attention to what the soil was telling them. And what the soil was saying for 300 years was simple. Feed me, and I will feed you. Starve me, and I will starve you back. The industrial world did not listen. It replaced biology with chemistry. It replaced patience with speed. It replaced observation with assumption. And now, 70 years later, the topsoil is disappearing, the water is contaminated, the food is nutrient depleted, the pollinators are dying, and the AI, the most powerful pattern recognition tool our species has ever invented, is pointing at a man walking behind a horse in Pennsylvania and saying, he had it right this whole time. The AI confirmed what the Amish always knew. The question is whether the rest of us will listen before the topsoil runs out, because the clock is ticking. According to the United Nations Food and Agriculture Organization, at current rates of degradation, the world's topsoil could be functionally depleted within 60 years. 60 harvests. 60 growing seasons between now and a global food crisis that would make every famine in history look like a bad harvest. And the man with the horse is the only one whose field will still be producing food when the clock hits zero. He will still be walking behind his team, turning the same soil his ancestors turned, growing food in dirt that has been alive for 3 centuries and will be alive for 3 more. While the fields around him, the fields that fed a nation, the fields that won wars and built empires and fattened corporations, will be sand. That is what the AI found, and that is what the Amish always knew. The only question left is whether we learned it in time. Subscribe. Because what the AI is finding beneath the surface in deserts, in scrolls, in paintings, in ancient tombs, and in the soil under our farms keeps telling us the same thing. The answers were always there. We just stopped looking. The next file is on your screen.